Next, we have an awesome speaker from Italy, seasoned developer from Italy, working at ToughWorks, brings 13 years of experience, distributed applications specializing in cloud technologies like Kubernetes and Terraform. A champion of modernization, Marco routinely assisted in migrating legacy software to web-based platforms. He has 2 dogs, loves cooking, and he's animal rights activist. So welcome on the stage, Marco Pierobon.
Thank you for the great introduction. My name is Marco. As mentioned earlier, I'm a lead developer at ThoughtWorks. I've been there for about 4 years, and I've been working on a number of different projects. Many of them were revolving around the cloud migrations, cloud optimizations, and so on. So I'm here today to share some of my experiences. A little bit about myself. That's me about a couple of years ago when I had normal hairs in the ThoughtWorks office in Madrid. When I joined ThoughtWorks, I was really looking forward to challenge myself and get to know people that are at the forefront of our industry. When we think about people that have been writing books, that have been pushing the envelope when it comes to new technologies, new ways of working, I found it in ThoughtWorks, and it's where I'm still growing every day. So actually, you have the QR code if you want to add me on LinkedIn. And a little bit about my company. You might have heard about us. We are a technology consultancy that was started in Chicago in the United States about 25 years ago. We've published over 100 books on any topic within IT, so from continuous integration, continuous deployment, to infrastructure as code, to the cloud operating models, to agile, to product management. Any topic you can think about in IT, we have a book written about it. We have over 100 books published on any specific topic you can think of, and we are very eager to help you in case you need some additional support in some of the most challenging problems you have in your day-to-day. You might also have heard about us for the Tech Reader. It's something we initially created and then we released as an open source tool that you can use for enterprise architecture within your organization and define which tools, technology, frameworks are acceptable to use within the organization, which are fine to experiment with, and which should be deprecated. Also, the Looking Glass is our internal vision that we share with the world based on the feedback we get from the clients and the client project, and we try to see what's coming ahead, what are the main drivers that we see happening in 3-5 years. Back to the presentation. The agenda for today is we first go through a quick introduction about what the cloud is and what are the different operating models we have within the cloud. Then we look at what the business drivers are that can push us in one direction or the other. A few examples that we've seen with our customers and that we've been guiding them toward. And we will conclude with how your path might look like when you approach a multi-cloud direction. So is there anybody here that doesn't know what the cloud is? Everybody knows? I can ask again. Is there anybody? Cool. All right. So for this very presentation, we will refer to the cloud as an offering from a company that involves solutions as infrastructure as a service or platform as a service. Sometimes other offerings, such as software as a service, are also counted as a cloud, but such solutions such as Salesforce here will not be part of the discussion. So if you use a product that is a software as a service, that will be out of the considerations today. But AWS, GCP, Azure, Heroku are good examples of clouds. when a company decides to move to the cloud, it embarks in a journey that is quite different from the regular one, where you go through a procurement process and you need to get budget approval, and you need to get, for every new server you buy or for every new license you acquire, you have a lengthy process that needs 200 approvals or a steering board committee. You embrace a transformation and you are essentially outsourcing your cloud needs. You can consider the cloud service provider as an external company that fulfills your cloud needs. And of course, this comes with a set of challenges. It really requires the people within the company to change the way they think about how the work is shipped. So when we think about procurement, we think about being predictable. We think about knowing what the workload is going to be in 6 months, 6 years. So we buy X numbers of servers, and we add 2 more next year because we expect the load to go up over time. That's not how the cloud operates. You want to favor experiments, you want to fail fast, you want to see what works and what doesn't. And you want to have the option, if the experiment is successful, to scale up quickly. But again, it's very different from the procurement model. Whenever you decide to move to the cloud, the first thing you should think about is which cloud service provider you want to choose. They all have compelling offers. Google, AWS, Azure have pretty sizable chunk of the market. They have pretty good service offering. But when we choose one of those, we should not do it based on a checklist. Like AWS has DynamoDB, which is arguably one of the best, or perhaps the best, database of its kind. Is it enough to choose AWS? Perhaps it shouldn't. We should much rather look at how the cloud service provider will evolve over time, what their roadmap is. Are they aligned with our way of thinking? If we expect a new feature for DynamoDB, for instance, is AWS going to fulfill it? So it's about finding alignment between our company and the cloud service provider. Also, when we look at so many different products available in each cloud, we can not really compare them against each other. It's very difficult to score Amazon DB versus Cosmos DB, because they are similar, but they're not quite the same. So we need to look at the concept of a platform, where Google is a platform, Google Cloud is a platform, Azure is a platform. How do they compare as an ecosystem against each other? Then, once we start embracing the cloud, we start seeing a lot of the common practices where we have segregated security checks, we have segregated infrastructure, we have dedicated teams that take care of those, and we need to go through those checklists for every release. That's not possible with the cloud. It doesn't make sense. Even if your company does it operating in the cloud, then there's something wrong. You are not using the cloud to its full benefits. And once we think about having resiliency in an old procurement way, we need to buy the capacity before. So if we have a disaster plan, we need to buy the servers in case there's a disaster. With the cloud, that's not needed. We have a failover plan, a disaster recovery plan, and automatically it happens without upfront costs. So what are the principles we should guide ourselves with? If we have more than one cloud, we should not expect it to be uniform. We should not expect to have always a seamless user experience, irrespectively of which services from which cloud provider we are using. That's a nice to have, but that should not be an assumption. Sometimes when we choose to move to the cloud, we are doing it because what we need is not available yet, and we want to build it. And sometimes it makes sense, because we get a competitive advantage that can give us more market share or can make us the market leaders for the next 10 years. That's a very good case. very good business case that can be made. But sometimes it doesn't make sense. So if you try to push the envelope too much, to always be before what's coming next, you might actually miss the mark. So sometimes it's better to take a more conservative approach and see where the cloud service providers are going, and then take the service from them. Whenever you build something for the cloud, you want to make sure that you are catering for the most possible the biggest use case possible, and that every team can reuse it. That's not always wise. You want to instead focus on the specific use case you need to fulfill, and then if there's a need for reuse, you try to make it happen. Similarly, whenever you are building a new set of API, for instance, you shouldn't try to make it compatible with all the callers. You should just make it so that, for instance, the front end needs this data. This is what we need to build. And the same thing applies for cloud technology. So if you want to make an API that calls something in AWS or in Azure, it needs to be the bare minimum. I need this set of input, and this is what happens. So having cleared the cloud principles, let's now look at the cloud operating models we've seen most often. Starting from the top left, we see the monocloud. In this presentation, here we mean that we are either on-premise, so we have our own data center, or we are in a single cloud. It's a neither. We cannot have both in this model. Then there's an option to move to the hybrid cloud, where we have some data center and some workloads in a cloud service provider. This is fairly common. Then we can start looking at polycloud, which means that we start having some specializations across two cloud service providers, and we decide, for instance, to run a specific workload in one and a different workload in another. Then the next evolutionary step could be looking at multi-cloud, meaning that the same workload can execute in different clouds at the same time. And there are some drivers that push us there. The most complicated and the least common is the distributed cloud, where you are essentially building an abstraction of a multi-cloud solution so that your internal development teams or your internal product managers don't really need to care about the underlying cloud service provider being used. And of course, this comes with some trade-offs. Any questions so far, by the way? Okay, going into more details. For the monocloud, this is the starting point for 99% of the companies. It's very difficult that a company starts with a hybrid solution or with a more than one cloud service provider solution. It's either existing servers you decide to buy or you have to buy, or if you don't have any servers and you don't have the capacity to maintain them, you start with a cloud service provider. Any workload that you create or that you need to maintain, we run in this cloud. And of course, it's the easiest to manage because it's a single point of control where you can expand the workload or remove it as you need. It's very common. It's what I've seen mostly among my clients. The next one. When we talk about hybrid cloud, we need to face that this is also a very common reality. If we think about older companies that were founded before the cloud, they had to buy some servers. Otherwise, there was no place to run their workloads. And there must be a phase, even if your ultimate goal is to move to the cloud, where you have both workloads running on-prem and workload running in the cloud. So you need to be aware of this dichotomy. Then, how do we get to the ultimate goal? Do we even want to get to moving everything to the cloud? There are some scenarios where this is desirable, and there are some others where you still want to retain your data centers. When we start talking about using more than one cloud service provider, and we want to have a specialized set of direction for what goes where, we are in the polycloud scenarios. So we can take as an example, saying that Google Cloud is excellent in terms of pricing for all the Kubernetes workloads. So since we have very heavy demands for running our workloads, we want to run there because it's much more cost effective. But then machine learning could be better, depending on what we need, in AWS. So we have those clear separations where any new machine learning algorithm or workload that we need automatically goes to AWS. And conversely, everything that runs in Kubernetes goes to Google Cloud. This can be regulated by corporate policies, defined as infrastructure as code, for instance, where you cannot spin any Kubernetes workload in AWS if your company doesn't want you to. So it's really closing the tap and making it impossible to execute. In this scenario, we are not caring about cloud portability. So we are not considering it an important factor to say, tomorrow, instead of using the Google Kubernetes engine, I want to move to Azure because I got a better price. This is not a consideration that we are making when we talk about polycloud. This is instead a consideration that is important in the multi-cloud scenario, where cloud portability is an important aspect. And this starts becoming necessary when there's a government or a regulator that mandates this to be present. So if you think about the UK, for instance, the UK has a plan for critical infrastructure that cannot be in a single cloud provider. Of course, it's not an immediate decision. The regulator allows some time for the existing companies to migrate to this approach, but it has to happen because mostly the possibility that a cloud service provider goes bankrupt, which is not likely to happen. It's very difficult to foresee AWS closing shop tomorrow, but it's not impossible either. So the regulator stepped in and is requiring now everything that is deemed critical infrastructure for the country to be multi-cloud. It's a very small subset of all the existing applications, so it might not be super relevant for everybody here. Another scenario here is that we want to have a disaster recovery scenario to play in a different cloud service provider. It adds a lot of complexity, for sure, but we isolate from failures of a specific cloud service provider at the region level. Finally, the more complicated and perhaps interesting scenario is when you have a single point of control and you are in the distributed cloud scenario, where you can imagine you have a control panel and you can execute the workload, and irrespectively of where they happen, you can just control them from a single window. So there's some level of abstraction that happens behind the scene. And of course, it sounds fantastic on paper, but it requires a huge investment, it requires an upfront commitment, and it requires to test things in multiple clouds at the same time. This is required mostly internally for a company, so it's very difficult that a regulator asks for this kind of solution. This is more whenever a company wants to have a multi-cloud solution, but wants to make it seamless for the internal users, and at the same time be able to meet compliance and scalability requirements across cloud. So just for curiosity, how many people here are monocloud, either on-prem or on a single cloud provider? Okay, about half. hybrid for 6-ish, polycloud, so 1. So again, this is when you separate the workloads based on the cloud. 1, multi-cloud, 1, distributed cloud, 0. Okay, so this is more or less the distribution I was expecting. I think some people didn't vote, so I don't know if you don't have the cloud or if you are using something different. If you are, I'm very curious to hear about it. So what are the business drivers that can push us toward using more than one cloud? The first one we can think about is a concept called best of breed, meaning that for each cloud service provider, we want to use the best services they offer, and we don't care who offers them. So going back to the example we made before, Google might have the best Kubernetes engine, might be the best in terms of price, might be the best in terms of location, and we want to say, even if we are an Azure shop, for Kubernetes workloads, we want to use the Google Cloud, because it makes more sense for us. The second driver is whenever you have a disaster recovery plan and you want to make sure that you can fail over to some regions that are not covered by your first cloud service provider. So you want to have a second cloud service provider as your disaster recovery target. There can also be some requirements about where your data is located. So this is also something that comes from the regulator most often. For instance, there are EU laws that require the data to be located within the EU. But then if we look at the UK, they have similar laws that require the data to be there. And if your cloud service provider does not have a data center where you should host your data, then you cannot use it. So you might still be 100% committed to a cloud service provider, but just for the data residency laws, you are forced to either migrate everything, which is, of course, very costly, or to move the parts that are mandated by the law to be stored in a specific region to a cloud service provider that has a data center in that region. Similarly, nowadays companies are facing more and more internal challenges about meeting carbon footprint goals, meaning reducing the emissions. And there are some cloud service providers that are more on the lookout for these trends, and they try to optimize the carbon footprint of their data center using renewable energies, building buildings that are more energy efficient, perhaps closer to the water or in a region that is less hot, so you don't need to spend as much on ACs, which are very expensive in a data center. Not all services provided by every cloud service provider are available in each region. This can start from whenever a new service is launched, and it's offered as a trial in some regions, but once it's GA, it can still be restricted in certain regions. And if it's the region where you are located or where your data needs to be, you might be limited and not be able to use that specific service. And you have to look at what the competing cloud service providers are offering in that regard. Also, some data centers might be far from you or far from your clients. And this adds to data latency. And in some sectors, like for instance trading, latency is a big factor. And you might be forced to opt to one cloud or to another based on these considerations. If you have very heavy workloads, or if you are a heavy user of the cloud service provider will start some sort of bidding war to get you. This can range from offering hefty discounts on your bills, but also to do some real investment work to get you to put more things into the cloud and essentially try to lock you in. By the way, lock-in is a concept we'll return in a moment. If you have workloads in more than one cloud, you can then start a bidding war whenever you want to move something to the cloud. Or you might consider moving things across clouds. So this is something you can play at your advantage. Of course, it's up to a point. You want to get things for free, but it's nice to see them compete for getting your business. Being locked in is one of the most common themes that come up when we talk about the cloud. So everybody is concerned about being locked in with AWS or with Azure because they are using managed services from them, and you can't find an apple-to-apple alternative if you move to a different cloud service provider. So what I've seen is that some clients are willingly not using those managed services. They are, for instance, running everything in Kubernetes. Instead of using DynamoDB, they run their own MongoDB instance, and they need to maintain it, which, of course, can make sense if cloud portability is a hard requirement. But if you're doing it just in case, you are essentially removing the main benefits that you get from moving to the cloud, because you are essentially still operating in a way that requires you to maintain your clusters, like, for instance, MongoDB clusters, your Kubernetes clusters. You need specialized people. You are more likely to incur in outages, because for as good as your people can be, it's very difficult to compete with the people that manage Kubernetes cluster at scale in Google Cloud or Azure or AWS. So a few examples I've seen with my clients. The first one is having a Kubernetes workload that spans multiple clouds. So there are tools such as Google Cloud Anthos, Rancher is also capable of it, that can orchestrate the Kubernetes execution across cloud, meaning that you get your pods to be run in different clouds, and if one cloud goes down, it gets balanced by the pods in the other cloud. This could scale to all the clouds you want. Of course, it adds complexity. So if you need to do it, and you want to do it across 2 clouds or 1 cloud and 1 on-prem deployment, it's already fairly complex. If you want to throw more cloud service provider into the mix, of course, it becomes more and more complex. Another example, and I think this is the most common scenario that people think when they think about multi-cloud, and it's essentially running pretty independent workloads, but of the same application in different clouds, and then they are committing the changes into their own database, but then the database you have is being synchronized in a master-to-master replication, for instance, with another database in a different cloud service provider. Of course, for doing something like this, you need to manage the database yourself. You cannot use a managed database in Azure and one in AWS. You need to set up a cluster yourself, and you need to configure the databases with everything that entails about network traffic, security, database roles, and so on, which can be difficult to manage. But this is a fairly common scenario. Another one, and I saw a few people that are using probably something like this, is when you want to say, for this specific type of workloads, ML, AI, just perhaps even databases, we use Google or we use Azure, but everything that is related to Kubernetes, we use a different cloud service provider. And there's very limited, if no, interaction between the two. Of course, every time you need to do cross-cloud communication, you need to take into consideration networking rules. You need to also consider the costs. Cloud service providers are cunning when it comes to data. So they let you bring in the data almost always for free. So you don't pay to push data in, because they want your data. They charge you when you get the data out. So of course, if you have cross-cloud, often recurring cross-cloud communication, you have data moving from cloud to cloud, and every time you have egress transfer, you're paying. So this is also an important factor to be considered. Another example is when you have parallel clouds. So you have clouds that are completely independent. You are using the managed service from each of them, and each of the applications being deployed saved in their own database. This is more common when you have different clients, and each client has some requirements to be on a specific cloud. So you want to say, for instance, that your client can only use Azure, so you build an application that tailors Azure components, and you deploy it in Azure for them. And another client has a similar requirement, but with AWS, so you build it using AWS services. Of course, this adds into the complexity, because you need to become, or you need to have experts that are knowledgeable in every cloud service provider you use. You need to take care of cross-cutting concerns across clouds like observability, cost optimization, and it starts becoming quite tedious when you have a moving target. So you have AWS evolving in one direction, you have, for instance, Azure evolving in another, and your people, or the people in your team, need to be always learning, always getting to know how those things are evolving in different clouds. If you are using a solution like this, you might consider a tool called Dapper, which is sort of a cloud abstraction layer. It's an interesting technology. You essentially depend on Dapper. It creates a sidecar container, and then based on what you have configured, it will take care of calling DynamoDB versus Cosmos at the endpoint you configured, and your application only depends on Dapper. Based on what we say about lock-in, we are not locking in on a specific cloud service provider if we build something like this, but we are locking in into Dapper. So we are just moving our lock, but we are still getting locked in there. So when we went across the room and checked who's using which cloud service operating model, we saw that many people are in different points. So how does your cloud journey look like? Or could look like? My take is that one cloud, meaning one on-premise data center or one cloud service provider, should be enough for your needs, unless there is a specific reason that forces you to make a different choice. And those, for example, can be when you have a disaster recovery solution and you have an on-premise data center, it's very costly and very difficult to build it on-prem as well. So you need to have a second data center located near from your office. You probably need to hire people there to be on call. So you need a very big upfront cost. You need to train people, and you have those overhead in communication that is probably not worth it. So if you have an on-premise data center, it makes sense to have your disaster recovery plan to target the cloud. Also, if you have a pretty stable workload without major bursts, but in specific occasions like Black Friday, Christmas, your traffic has ginormous spikes, you don't want to buy the infrastructure on-premise just for those few occasions. It makes more sense to burst into the cloud. So when we are looking at multi-cloud Kubernetes deployment, for instance, you can run your workloads on your data center. But for those moments when you need more capacity, you can burst into the cloud and use some additional capacity there. When does it make sense to enter the polycloud space? If you have very separated teams that are working on very different requirements, using very different technologies, then it can start to make sense. Because you probably want to have your AI department, your ML department to use the best services they can find or they can use. And they might be offered just by a single cloud service provider. And that might not be the one you're using. So in this scenario, it can make sense to use polycloud because there's limited communication and there's limited traffic between the different teams. Also, this becomes an option in case of data residency requirements. For instance, if the machine learning teams need to have the data stored in France, but your cloud service provider does not have a data center in France, then this becomes suddenly an option that you could consider. I added a warning sign here, so just as an indication that they should be taken with care. It's not something you want to embark in lightly. It adds overhead, it adds headaches, and it can risk to slow you down as a company. The next step in complexity is multi-cloud. Again, this is when you can run your workloads in a cloud-agnostic way, so you don't really care where they're running, they just run. This is quite complicated to set up and to maintain. So the only scenarios that I've seen warranting such an undertaking is when there's a regulating body that has it as a mandate, or when you tried everything else and nothing worked, so this is your last resort. Finally, the black sheep, or it could be the ultimate goal of the black sheep, it could be either. Distributed cloud only makes sense when you are in a multi-cloud scenario and you are struggling to make sense of the mess. See, having observability across cloud, spinning up different workloads and not knowing where they are. Having to do it in different places. When this starts becoming something that is really slowing you down as a company, you can consider having the distributed cloud approach. For this, you need a very strong platform team. By platform team, we mean a team, an internal team that serves the development teams. So they are building blocks, abstraction components that can be then deployed, reused, and extended by the development teams to make them more effective. But to build a distributed cloud solution, you need to have a platform team that is specialized across different clouds, that are well synchronized. And of course, even when this is the case, you can expect that each new feature that the platform team is going to ship will take much longer, because it needs to be supporting multiple cloud service providers. And of course, if the platform team is lower, it also means that the development teams become slower. So, circling back to the lock-in point. This is perhaps the most recurring theme when we talk about having more than one cloud. When we talk about what the cost of locking in is, we always, or almost always, think about the switching cost. So if we are using AWS, how much would it cost to move to Google, for instance? But that's just one side of the coin. In reality, when we want to reduce the cost of lock-in, we need to think about how much effort we are putting in terms of hours of development. We need to think about underutilization. So how much, sorry, can you make it big? In terms of complexity. So we were talking about Dapper earlier. So if we don't depend on a cloud-specific implementation and we have this middle layer that serves as an abstraction, is it making it easier for us? Probably not, because we have an additional dependency that can have bugs, that needs additional observability, that needs additional expertise. So is it worth it? And when we do something like this, we are trying to get away from the lock-in, but we are getting locked in into something else. So when we think about the switching cost, we need to think about what the upfront cost is. For instance, if we think about moving a pipeline so that it supports multiple clouds, having scripts that can run in different clouds, how much that cost will be, and then we need to factor in the probability of switching. So this is like the estimated value and probability. If you have a 5% chance, but we need to spend $100,000, for instance, just to be ready to be portable one day, is it really worth it? Those are considerations that need to be made before considering portability an actual requirement. When we are building cloud applications, many times portability can take a back seat, but we can still build applications that are optimized for the cloud and that are easier to be moved to a different cloud service provider later on. So there's an acronym, FIRST. So you want your application to be frugal, meaning that they do one thing and they do it well, and they are not overcomplicated by additional logic that you might or might not need in the future. They are relocatable, so they don't depend on specific resources. If you think about, for instance, something that can run on Kubernetes, it doesn't really matter where you run it, and it's much easier to move it later on if you need it. It should be observable, meaning that it should integrate well with observability tools, so you know what happens. And of course, if you combine this with it being relocatable, it means that wherever you run it, you have good visibility over what's going wrong or going well in your application. It should be easy to be updated, so it shouldn't be more hard or less hard to update if it runs in one way or another. So if you think about running an application locally with Docker or with Kubernetes, it should be as easy to be updated. It should have security as a first-class citizen, and it should be able to survive failures. So again, Kubernetes as an example, if there's a problem in a pod, another one is spun up, and you've taken care of some of the main considerations that will then make your application portable. So this takes us to the conclusions. We've seen that the majority of the people here are using some sort of cloud, and some of them are perhaps a little bit far ahead when it comes to looking at how the cloud can operate. But we've also seen that there should be a specific business driver that pushes us there. We shouldn't be taking a decision to change cloud operating model lighthearted, because it comes with a lot of additional consideration, a lot of additional cost, and sometimes also additional headaches. I hope you've enjoyed it. You have here the QR code for a quick anonymous form for some feedback.
Yep, so thank you, Marco. Thank you for such insightful and structured presentation. So do we have any questions from the audience? Yep.
you. Hi, I'm Roni.
Hi.
You mentioned at some point it could be useful to have different clouds and use that as a reason to get discounts or to push discounts from each cloud provider. Actually, we currently are on many clouds, and we're thinking of moving to one cloud while staying cloud agnostic, so we can get bigger volume, so we can get discounts. But I guess your strategy kind of contradicts with what we're doing, and I guess both make sense.
That's a great question. So it relates to what we were saying earlier, that you can play the cloud against each other once you are in more than one cloud. Now, of course, you've probably seen that the complexity of being more than one cloud is not justifiable, and you want to set on one. And now you are trying to start a bidding war for the cloud service provider to get your business. Is that correct?
Mainly that we're trying to move all of our volume to one cloud, just so we can get a bigger discount. And I didn't think of, in the contrary, splitting our workloads across different clouds in order to get discounts. My thinking was more to go in bigger volumes.
So what I was referring earlier is that if you're already into clouds and you want to bring in new business, perhaps a new business unit or something you have on premise, you can contact both clouds and see the best offer. You are using the same aspect, but for closing one cloud or closing your account in one cloud, which is also very, very smart.